So what additional on-site documentation is required for your next commercial solar project? Let's find out. Hi, I'm Veli from Greenwood Solutions. Part 2 of a two-part series on commercial documentation, on-site specifically. Now, after watching the video, you'll understand the benefits of on-site documentation, what kind of documentation to use, a bit more detail than part 1, and how it improves the whole process of the commercial solar installation procedure. Now, if you like what you see, hit that subscription button. And if you want us to make more of these videos, hit that subscription button again. Okay, let's get stuck into it. In our last presentation, we looked at some of the documentation that is needed on site to assist in the installation process being fairly painless. Now we look at specific site installation documentation around the overall site plan, feet and rail placement, cable string configurations, panel positioning. We're talking a very large roof where the 500 kilowatt or so of solar barely makes a dent in the available area. Now, the main component list includes 5 by 100 kilowatt inverters, each having 6 maximum power point trackers and 2 inputs per tracker, a total of 60 strings, using a 400 watt panel, and there's 1,380 of those, framing and cable to suit. Let's get stuck into it. In this example, I used a near map image of the roof, got the correct dimensions and imported it into AutoCAD. Once in AutoCAD, the image needs to be dimensioned correctly so the various components can be drawn to the right scale that will show a realistic layout. This is where the accuracy of the line drawn in near maps comes into play. I've used AutoCAD, but other CAD style programs can be used. Ideally, when you draw in AutoCAD, different objects should be placed on different layers. For example, the first layer could be the near map image and then layer upon that like a sponge cake. In this case, I've drawn the outer perimeter and then used a gradient fill to show where the system goes. Could also put notes into this image as well, such as the brand, model and number of inverters used, framing used, panel brand, model and number, and notes concerning inverter and PVDB position. Now we can show the overall layout of the feet and framing with specific differences outlined if there are any. In this case, the section on the left is different from the right. Also can show the inverter section parts. In this case, there is 5 inverters. Could also list the amount of framing and feet used. In this case, framing lengths of 4,200 mils and there's 736 of them, and there's 3,040 roof clamps. By showing an overall view of the layout, it allows the installers to understand how it all comes together. Now we can drill down a bit and show the dimension of the small rows in the entire framing configuration. For example, we have an 11 panel and 12 panel section side by side, which is different from the other section. As with the small rows, we do the same with the rows that consist of 23 panels unbroken. Could also add notes that mention the internal cable configurations will be different between the 2 row types. Another site layout is for the cables, and this gives the installers an overview of where they are all going. In this case, the cables have 3 different configurations: 11 and 12 panel cabling, 23 panel unbroken rows, all cabling to the right, and 23 panels unbroken rows, all cabling to the left. Notes could be added showing what actual DC cable is being used and string configurations. In this case, we're using 4mm and 6mm twin, and all strings are 23 panels each. Configuration design has tried to minimise the differences between positive and negative lengths, and we go on a little bit with some more details there. And then at the end, see notes for more details. This drawing shows the actual panels in situ on the unbroken 23 panel rows. The blue dots signify the first and last panel in the string. Notes can be added to point out the cable run. Big row cable layout with panel step 13. The cable direction, etc. can be further outlined with arrows if this helps. Showing the panels in relation to the cable really helps visually and reduces mistakes made in the installation process. Notes can be added concerning cable tray cable loading maximums, and in this case, cables to be consolidated here where the cable tray is positioned. Note max of 28 by DC cables in 150mm tray due to derating factor, all parallel strings in 6mm squared minimum. See notes for details. The overall layout showing frame and feet is also a good place to outline some general notes, such as showing inter-row cable runs, cable run row to be enclosed in galvanised conduit, see yellow dot. Cable tray requirements, in this case we're using 150, 300 and 450mm tray profiles. A nice table outlining some of the details required in the installation process also helps. This table can reference certain drawings and other notes in the site documentation. So we're just looking at the number of inverters used, the number of different row lengths, panels used, number of string configurations, panels per string, the area of the install, longest perimeter, the cable tray used, and various other details. Conclusion. The examples given above are just the tip of the iceberg. At the end of the day, site documentation is there to help all the processes flow. Attention should be given to making sure all drawings are fairly easy to read and understood at first glance. By showing overall views as well as detailed ones, the visual aspect of the install becomes reinforced in the mind of the installers. This documentation should be constantly improved from one project to the next. Thanks so much for watching our presentation on Commercial Solar Documentation Part 2. I'm Veli from Greenwood Solutions. If you have any questions, any inquiries, even any answers, feel free to drop us a line. If you like what you see in regards to us making these videos and you want more of them, hit that subscription button. See you next time.